Hello, welcome. In this video, we are going to look at the measures of central tendency, which are generally referred to as the mean, median, and mode. We'll talk about all three of these in this video. So the mean is the thing that everyone loves to call the average, but we actually call it the mean. This is what we get when we add up all the data values and divide by how many data values there are. The term average is a general term that actually applies to one of several different measures of central tendency, depending on the type of data we have and the situation that we're dealt. So we'll talk about that later in this video, but for right now, let's try and find the mean for this set of data values. We have 4, 6, 9, 3, and 2. To find the mean, we will just add up all of the data values and then divide by the number of data values that there are. So there are 5 data values, we will divide by 5. We actually call this the n value. Let me make that a nicer n. This is supposed to be a lowercase n, and that's good enough. So n is 5. So we'll just add at the top. 4 plus 6 is 10, plus 9 is 19, plus 3 is 22, plus 2 is 24, divided by 5 is 4.8. So the mean is 4.8. For example 2, it says calculate the mean monthly expenses for the past 6 months for someone whose expenses were $800, $950, $700, $850, $900, and $750. We know that there are 6 months, so we know that once we find the sum, we will divide by 6. So let's add these up together. 800 plus 950 plus 700 plus 850 plus 900 plus 750. So we can just add these up. 800 plus 950 plus 700 plus 850 plus 900 plus 750. Now, what some of my students do is they will say divided by 6, just like this. And the issue or the concern is that really because of the order of operations, because of PEMDAS, this division by 6 is only being applied to that last number. If you want to do this all in one step, we need to use the parentheses and group the numerator in parentheses and then divide by 6. The other way around this is to just find the sum first and then divide by 6. So we get 4,320 divided by 6. We get a mean of 720. All right, so that is how we can find the mean. The next measure of central tendency that we will look at is the median. A highway median is the part in the middle. Similarly, the median of a set of data is the middle number in the ordered set. A common mistake that students make is that they do not arrange the data values in ascending order first. So we need to make sure that we arrange these in order from least to greatest first. So we would not say that 9 is the median, because 9 is not the middle number in ascending order. It's just the middle number in how it's written. So first thing we're going to do is rewrite these. So 2 is the smallest, 3, 4, 6, and 9. From here we can cross off the outside numbers in pairs until we're left with just the one middle number. The median for this first example is 4. Now this works out nicely because similar to what we were saying before, the n value, the number of data values is 5. 5 is odd. We have an odd number of numbers. It's just the middle value. What we'll notice, for example, 4, where we're asked to find the median of the set, is that we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 data values. Since we have 10 data values, we're going to need to find the middle of the middle. And I'll show you what I mean by that. So first thing we're going to do is arrange these in ascending order from least to greatest. So the smallest number is 3. Then we have 5. then we have a 6 and another 6, and then a 7, and then a 9, and then a 10, a 12, a 13, and a 17. I always like to suggest that we cross these off just to make sure that we have the right number of numbers. We can also just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have our 10 numbers. We are good to go. So again, I'm going to cross these off in pairs to find the middle numbers. So that's 2 pairs, and then 3 pairs, and then 4 pairs. And you'll notice at this point that we now have 2 middle numbers. So we have the numbers 7 and 9 as our median. But we can't have 2 middle numbers. There's only 1 middle number. So we're going to find the mean of the 2 middle numbers. So the mean of the 2 middle numbers, we're going to do 7 plus 9 divided by 2, which would be 16 over 2, which would be 8. So the median here is the number 8. It's the number that would be in the middle or is in the middle of the middle numbers. For example 5, it says a small tech company has 4 employees that each make $50,000 per year and a CEO that makes $200,000 per year. What is the mean salary at the company? What is the median salary at the company? And then which average is the better description of the average employee salary? So to find the mean, we need to add up all of the employees' salaries. In this situation, we know that we have 4 employees that each earn $50,000 a year. So we would have 50,000 plus 50,000 plus 50,000 plus 50,000, which is 4 of those employees, right? So 50,000 plus 50,000 is 100,000. So 200,000 plus another 200,000 would be a total of 400,000. So total income or total salary for these employees is 400,000, and we know that we have 5 of them. We have 4 that make 50,000 plus the CEO gives us 5. So the average or the mean, sorry, I slipped up. The mean salary for all of these employees would be $80,000 per year. Next, we want to find the median. The median would be the middle number. And we already have the numbers listed in ascending order from the first step. As you can see, we have a 50,000, a 50,000, a 50,000, a 50,000, and then a 200,000. The middle number would be $50,000. And then the question says, which average is the better description of the average employee salary? Remember, when we're talking about the average, we're talking about like all of the different measures of central tendency. In this case, we see that the mean is 80,000, but there are no employees that make 80,000. There are 4 employees that make 50,000, so less than 80,000, and there's 1 employee that makes 200,000. So this $80,000 per year income is actually not a good descriptor or not a good representative for any of the employees. And I think that the median is the better representation. Median is the better representation for the employee salary. So 2 things that we could talk about here. The first thing is this $200,000 the CEO makes could be considered an outlier. When we have outliers, the median is generally the better representation, or the median is the better measure of central tendency to use to represent the data values. The other thing which I didn't get a chance to talk about with this very first example back here with the mean is that the mean represents the balancing point of the distribution. If I were to put all of the data values from this first example on a number line, let me just slide this up and out of the way a little bit. If I were to put all of the data values on a number line. So we have the number 2, and then the number 3, and then the number 4, and then the number 6, and then the number 9. The mean of 4.8 really represents the balancing point of these data sets. So this number 4.8 would be the mean here, which if you look visually, it kind of looks like if you were to actually pick this up and put this number line on that fulcrum point, on that balancing point, it would balance there. So that's what the mean does. The mean is also known as the arithmetic mean. You don't need to know what it's called, but that's what we're talking about with these. All right, so that's the mean and the median. We also talked about why we would use the median. Oops, wrong example, this one. We would use the better representation for employee salary because there is an outlier in this data set. So we have one more example, one more measure of central tendency we need to talk about, and this is the mode. A third descriptive measure of a data in this is the mode. The mode is the single data value that occurs the most often within the data set. In the previous example, the modal salary of the company is $50,000 because there are 4 employees that earn $50,000. So again, the mode is the data value that occurs the most often. Example 6 asks us to find the mean, median, and mode of the exam scores listed below. Round your answers to the nearest tenth as necessary. So to find the mean, well, first thing we need to know is how many data values we have. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. We have 20 data values. So we need to make sure that we divide by 20. So in our calculator, we'll just use parentheses, open parentheses, and then just start typing in the numbers. 93 plus 97 plus 59. All right, I'm going to pause the video here, and I'll show you the results. I would suggest that you pause the video here as well and confirm that you get the same answer as me. So we'll use the closed parentheses once we've typed all the data values in, and then we can press divided by 20. And as long as we put this all in parentheses, we'll be able to do this calculation in one swoop. So the mean here, the mean is 77.4. To find the median, we need to again arrange these in ascending order. Now this is going to take me a second, so I'm going to pause the video here. I'd suggest you do the same as well. So far I've got 57 and 59, and then I realized that I had a 58, so I needed to put this back over. Again, crossing these off and going nice and slow through this list a few times is going to be the best way of making sure that we get all of these values in ascending order. All right, so now I have all my data values in ascending order. I missed a few of them. I missed 38 at some point. I missed 73 at some point. I need to move this stuff around. So basically what we're going to do here is we're going to look for the middle value. Now, some textbooks will tell us that we can find the middle value by taking the number of data values, adding 1 to them, and then dividing by 2. So 21 divided by 2 would be 10.5. When that would mean that the middle value, or the median, would be between the 10th and 11th value in order. I'm not going to worry about that for this lesson. We're just going to worry about crossing these off in ordered pairs. So this is a pair of data values, so I'm going to do this in pairs of 2. 94 and 57 are 2 digits away. 93 and 58 are 2 numbers away. 3 numbers away. And then 91 and 59 are 4. 68 and 89 are 5. 71 and 88 are 6. 87 and 73 are 7. 76 and 85 are 8. 84 and 79 are 9. And then we're going to look for the mean between 79 and 82. Again, as I was showing here in blue, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it'll be between the 10th and 11th data value. Again, we don't need to worry about the blue stuff here. I'm just showing you 2 different ways of doing this. So the median would be the values between 79 and 82. So we just do 79 plus 82 divided by 2. If we want to do this in the calculator, we can just make sure that we put this in parentheses. Oops, I messed that up. Parentheses, and then divided by 2. And we'll get that the median is 80.5. Probably should have written that in red. Keep it color coded. That's okay though. And then lastly, the mode is the data value that occurs the most often. The mode is the data value that occurs most often. And now that I have it in ascending order, I can just look for any values that might repeat. 38, 57, 58, 59, 68, 71, 73, 76, 79, 79. These two repeat. 82, 84, 85, 87, 88, 89, 91, 93, 94, 95. So 79 is the mode. It's the only data value that repeats or has two of the same. All right, one last example. Imagine you survey a group of people about the types of pets they have. The responses are as follows: dog, cat, dog, bird, dog, fish, cat, dog, and hamster. Find the mode for the most common type of pet. Notice with this particular question, we couldn't find the mean and we couldn't find the median. There is no ascending order for these, and there is no values to add and divide by. The mode is the only measure of central tendency that we can use to find the most common type of pet, or the average pet for these people. And in this case, dog wins because it has 1, 2, 3, 4. So dog would be the mode, and is the only value that we can find for this. Thanks for watching.